also. So later, we can share it with Francis, and I'll try to, if it gets recorded, I think I'll try to share this. Okay. Chalo, let's start off with the session. So we are going to do today about indexes. So generally, what exactly is indexes? Where we have come across indexes.
Python.
When I talk about indexes are nothing. Where do we see indexes? Where do you come across the index concepts?
We learned it in Python, no?
That is like when you're searching the slicing and thing. But otherwise, other than programming in general, indexes we use it in the books.
Beginning होता है ना? Book का beginning होता है ना?
Book का beginning generally we call it as a content. Generally, when we have some big books, the reference materials, at the end of the book,
is the last.
At the end of the book, we have some kind of thing called as the indexes. In the indexes, what is there? So you'll have some kind of important words or the topics will be there, and it says about this particular word in which all the page number it has been discussed. Information is there. Okay.
Correct.
So you want to see, like, I have a computer book. I want to know what is memory. So what I do, I'll go to the index. So in the index, all these particular words will be sorted in the alphabetical order. So it becomes easy for me to locate where that particular memory is there. And next to that, it says, so information about the memory is discussed in so and so pages. Okay.
Right.
And directly I jump to the respective pages and try to find out, oh, this is what is memory. This is how the memory looks. More detailed information about the memory I can extract. So that means what exactly we are trying to do is, so when the book is big, instead of scanning that whole book and then searching the information, I can just, through the index, I can directly point to the respective location and I can pick the information, what is needed. Yeah.
Okay.
Okay. So that is mainly, okay, I can say generally with the help of the indexes, so it makes my searching job easy. Okay. Now, when it comes to the database, a database is dealing with a lot of data, a huge amount of data. Okay. So the tables, rows and columns and things. Now, when I say I have the data, in the data, so we'll be always fetching for some information. No? I want to see a particular student, or I want to see a student who's based on the marks or based on the what course he has joined. Based on the various criteria, I'll be keep on fetching. Always, like it comes to the database, we always keep searching the information. So when I say like we are searching this information, we need to have a better technique to search the information. Just like in the books, without the index also you can search, but with the help of the index, the searching becomes easy. Yeah. So now the same way, when I say if I'm using a database where we'll be searching for the information very frequently, we should have a technique where the search can be made it more simplified, more easy. Okay, to fetch the info. Okay, that is the purpose of indexes. Now, we have a lot of things in this. What I have made a note, so we'll try to find out what exactly is index. We have something called as different types of indexes. We have again a clustered index as well as we have a non-clustered index. We'll look into that. Okay, then finally we'll see determine when indexes are useful, when exactly has to be used, and there are some other additional options here, like say fill factors and all this thing. We'll just have a look on this particular things. Okay.
Yeah, I think we have lost Francis again. I think we can continue.
Lost, yeah, he has some network issue. Anyway, the record is going on. The recording is happening. Yeah. So I'll just share this recording. Okay.
Okay.
So generally, when I talk about an index is in a database is similar to index in a book. So generally, in a book, how do you search for the information? Which is similar to that is the indexes. Fine. Allows the programmer. Okay, allows the program to find the data in the table without scanning the entire table. So that means you want to fetch for some information from the table. Instead of you scanning the complete table, you should be able to directly jump to that particular location and pick the information, whatever is needed. Okay.
Right.
Yeah. It provides a faster access to the data of the table. The main purpose of using the indexes, when you're searching for some information, my search has to be faster. Okay, that is what is the mainly thing. So by applying the indexes, we can also enforce the uniqueness on the rows in a table. Okay, so these are some points about the index. I'll go ahead.
Got it. Yeah.
So it's something like at the end of the book, you look something like this, no index, all these particular topics with which is sorted in the alphabetical order, and we can easily locate what it is and the respective page, and then jump to the respective page. Some of the guidelines for creating the indexes. A column can be selected for indexing based on the following criteria. Say it says the like a table, like when you talk about my customer table, so which is actually having some 15 plus fields, so I can have indexes in all the fields also. Okay, but it also has some kind of a what you say, overhead, performance overhead. So something similar to yesterday we was talking about triggers, no? So when I use too much of triggers unnecessarily, you'll have a performance overhead, so due to which, you know, it can slow down your activities. So the same way, if I use the indexes for all the columns unnecessarily and all these things, you will have a performance degradation. So actual objective of using the indexes is to improve our performance. Okay, so based on that, this is like when to use index, when not to use the index. Okay, a column can be selected for indexing. That means again the indexing is given within a table for the columns of the table, the fields. Okay, so give the indexing on the columns that is used in the search criteria very frequently, or columns used for sorting the data, or okay, do not index on the columns in the following cases. The column contains a very few unique values, so they don't contain the repeated values. So like say example, address. Okay, so every person will have a different address, so don't try to give indexing on those particular, or don't give the indexing on the subjective column also. Try to give in the indexing on the columns of a smaller length. Okay, and also it is not recommended to give the indexing on the smaller table. Smaller table means if a table has say 20 rows. Okay, and if you create an index, so for that it creates a separate table, index table, and then the searching happens through indirectly. So this can again slow down. But a table has thousands of rows. Okay, in that case you need to have a better technique to search. It's something like, you know, you have a novel. Novel is sometimes 15-20 pages or 50 pages. So for that, generally you see will not have an indexing at the end of the book. But when it comes to the reference material, 500 pages or 1000 pages of book, so in that case, you know, people will not be happy to scan all the pages of the book. So they want to have a technique where they should be able to locate it, what exactly they are looking for. Yeah. Yeah. So use the indexing on a table when the table length is very large. Give the indexing on the columns, which is used in the search criteria very frequently. And by default, when you create a primary key on a table, that particular field will by default will have an index, or you can also give the index on the primary key. Okay. Right. So this is what it is trying to say. Don't give the indexing when the data is too less or things. So do not do indexing. But it is very much essential when the size of when your data is large. Okay. Right. Yep. Now, how do we create an index? The syntax of creating the index. So we'll look into it. Now, the syntax for creating the index is something like this. See, when you're creating, we just say create procedure, name of the procedure or something, no? When it comes to create table, we say create table, name of the table, create procedure, name of the procedure, create view, view name. So we say create index, but before I create an index, we have different types of indexes. We have something called as a unique index, clustered index, non-clustered index. We say create what type of index, then we are telling, oh, we are trying to create an index. The caps keywords are the keywords. And this is the actual name of the index that you want to have, on what table, and in the table for a specific column you're trying to give the index. Got it? Right. Yeah. This is the syntax for creating an index. We say create the type of index, then we are telling, oh, this is the index, so we say use the keyword as index. Then you give the name, whatever the name you want to give for the index. So that will be this particular name, on what table, and index is given for a column of the table. In the bracket, we specify the column. It can be a single column, or it can even be a multiple columns. Apart from that, we do also have some kind of optional parameters. We have something called as the pad index, the fill factor, drop existing. These are optional. So, okay, we'll talk about this later. I think it says unique, clustered, non-clustered are the different types of indexes that is there. Pad index specifies the space to be left open on each page in the intermediate levels of the index. See, something like, you know, when you're storing the data in the database, this one, so the information is stored in the form of pages. So each page size is around 8 KB, 8 kilobytes. Okay. So now what happens at the end of each page, if I give a pad index and the fill factor, so it gives you some kind of a space so that it can use for rearranging the data. This kind of search and all can be made easy. So you have some kind of extra space, so rearranging and all can be made easier. So if you want to define those things, we can use this particular thing. Yeah. Fill factor specifies the percentage of the leaf level of the index page. Drop existing, if an index in the name exists, this option drops the old index and before creating the new index. Okay, just like an alt command. Okay, fine. This is the syntax of how do we actually create the indexes. Clear?
Right.
Okay, so this with option. See, when you, I think I had discussed about this from long time. Say, when you see in the syntaxes anything within the square bracket, those things are optional. So that means these are optional. Okay. Francis is very frequently going off and on. No problem. We have different types of indexes. We have a clustered index. We do also have non-clustered index. See, generally, when you look into any authors, any books and all these things, they talk only about these two types of indexes. That is, we have a clustered and the non-clustered index. But at the same time, some authors, they even discuss about the unique and the composite index. But actually speaking, we have two types of indexes, clustered and the non-clustered. So I can say unique and the composite is the subdivision under that. Okay.
Okay.
Okay. So totally I have given as 4. So when you refer to the various Googling and all these things, some places you might see 2, some places you might see 3 or 4, all are fine. So it depends on how they have explained. All authors are good.
Okay.
Okay. So we'll try to understand what exactly is a clustered index. Okay, first, and then we'll try to understand what is non-clustered index. Until that it comes to the unique and the composite, we'll try to understand this also. Okay. So first I'll go to the clustered index. It says a clustered index defines the storage order of the data in a table. Okay. So it says a clustered index, okay, determines the storage order of the data in a table. Okay. A table can have only one clustered index. It can comprise of multiple columns. It is effective on the columns that are accessed very frequently. Got it?
Yeah.
Oops.
I am here. I'm listening.
Yeah, you understood. So I don't know how far you have understood. I'll just say a clustered index determines the storage order of the table in a table, order of the data in a table. A table can have only one clustered index. Okay, it can comprise of multiple. That is, one single index can comprise of more than one column. That is what is called as a composite index. It is effective on the columns that are accessed very frequently. Okay, see, I can just give an example. You see the dictionary, no?
Mm-hmm.
Yeah, dictionary, or you talk even about telephone index book or telephone dictionary also, or our English dictionary. So in the dictionary, what happens is the whole book is been indexed. Yeah.
Mm-hmm.
The complete data from the start till the end, the complete information has been sorted alphabetically, A, B, C. Okay, all the words starting with A, then B, and then C, and forth on. Now you want to search. I want to search the meaning of computer. What I do, I'll just go to that particular page where the information, the words are starting with C or COM or something. Fine. And there I'll try to find out where is the computer. And then I say, oh, this is the actual definition of computer. Fine. Right. So now, here what is happening is it is sorted based on the key, that is your words, and we have a definition, the meanings next to that. The whole book is by default, it is arranged in an order, and then the searching takes place. Okay, this is one type of indexing. The other type of indexing is mainly like your books. In the books, what happens is you have 1,000 pages of book. At the end of the book, we have something called as a index. So where we'll have all the topic names, and then it says in which is sorted in an order, and then it says this information is covered in so and so pages, and directly we link. Then we link to the respective page, and then try to extract the info. Okay, here we are going to the index, and then from there we are locating it. Okay, so I can say in the books there is a separate index table created, and from there we are locating to the respective page. Yeah.
Right.
Okay. Now I can say clustered index is like your dictionary.
Achha.
Okay. The complete table will be sorted. The field on which you have defined a clustered index will be sorted based on that field, and the searching, what happens, it happens on that particular field. So whenever you try to write a query, okay, say example, you have all the employees, this one, we have thousands of employees, and I'll make the employee ID as a clustered index. When I make the employee ID as a clustered index, whenever I try to search the data in the employee table, so first it will ensure that the data in the employee table is sorted based on the clustered column, that is the clustered index column, that is the employee ID. Okay, then the searching happens. So now if I'm looking for an employee ID which is 5025, so what happens? Okay, it goes directly after that, is since it has been sorted in order, it directly goes after 5000, it locates that and then it fetches. So just imagine if it is not sorted, okay, it becomes very difficult to locate, is it?
Francis, mute it here.
I am just now connecting. Sixth time I'm connecting, man.
I know you've been going on and off.
Getting irritated.
Okay, this is about your clustered index. Fine.
Right.
Okay, so that is the reason it says, like, you know, when you apply a clustered index on column, that column will be sorted and then the searching takes place. So that is the reason they say a table can have only one clustered index, but that can be compromised of multiple columns. So you can have employee ID and the date of joining together as one, this one, or like say student roll number of a student with the class name and the section name. All three field together can be indexed. Okay, and then searching can happen. Okay. Fine. This is an example how exactly a clustered index. So we have the employee data. So you can see we have CN02007. We have something say 12 and then say 30. Fine. It is not in an order. It is not in an order. Okay. So when I define a clustered index on this, so that means if I define a clustered index on this particular column, so after you create an index, you can see this data is sorted here. You can see 7, 12, 20, 30. And then the searching happens. So it becomes more easy, okay, for the pointer to locate what exactly data you're looking and then fetch the complete row. Fine. Okay, internally behind, so even the data is like this. Whenever you apply a search, okay, so it will put something like this and then the searching will happen. Okay. So we do have something, okay, that was about your clustered index. I will come to the practical, this one. Okay, first we'll try to understand this. Okay.
Okay.
We do also have what you call it as a non-clustered index. Non-clustered index is similar to your textbooks or the reference material, what I was talking. A non-clustered index specifies a logical ordering only. A table can have multiple non-clustered indexes. A table can have multiple non-clustered indexes. So it says it can have up to almost 250 indexes. Okay. Then it says it is similar to a textbook index. The data is stored in one place and the index is in another place. Fine.
Right.
Okay. So now when I show you the example here, again, I have some kind of a customer data. Now take an example. We have many customers from Spain. We have many customers from Germany. We have many customers from Russia, London, and things. So we have taken a small checklet of the data. Now I'll try to create a non-clustered index on this column, say country. When I create a non-clustered index, now what it does is, whenever I try to search for the data, say select star from customer details, where country is equal to Germany or something like this. So, and if I have a non-clustered index on this column, so when my query will automatically create one index table. Okay. So this again will be created in the RAM for a temporary period of time till your query is running. Just like yesterday I was talking about virtual tables. So in that, what happens is, what all the distinct countries are there means what you say repeated countries will be shown only once. So that countries will be taken and will be stored in this in a sorted order. You can see G, L, R, S. Okay, is sorted.
Right, right.
Now, if I'm looking for, say, London, it goes alphabetically and locates where is London, and then say, oh, London, this record is there in London. There might be another record which is in London. There is another record which is in London. It fetches all those particular pointers which is looking, and then it will fetch the data.
Okay.
Okay, so this is how the fetching happens. So I can say mainly we can use a non-clustered index on those columns which has more repeated data, and those columns which is used in the search criteria very frequently. Like I have, say, example, I have the student who is joined for the different courses. Now I always keep fetching the data based on, I want to see the data analytics course student, or say Java students or Oracle students or something based on the course. I keep fetching on that course column. I can define this particular non-clustered index. That means the column data where it has a repeated data. Yep.
Got it.
Okay. So what is it? Okay. Now I
But
think
this
is
works a
major
little
two
slower,
types
I
of
guess, no?
Yeah.
Does this work a little slower than clustered?
Yeah. See, like, it depends on size of the data, and how, see, like, if you have an address and all those things, it will just become drastically slow. Yeah. This is using a separate table, and also it is using it is using a resource also here. Memory is very important resource than your hard disk. RAM is very expensive, no? So this is
Right.
blocking even your RAM also. But you say, example, I have some 5,000 rows. Out of that 5,000 rows, I have 10 customers from Germany. So now if I'm not using the non-clustered, when you write a query, the search has to happen for every row, so that search will happen 5,000 times. But here, out of that 5,000, so we might have only for 10 different countries. Okay, we have the customers from 10 different countries. The index table will have only that particular 10 different countries here, and that countries will have the link to that respective this one, and it will directly link to that respective columns, and then it will pick. So in that basis, it will be faster.
Right.
Okay, and that is why, like, we use the non-clustered when you have more of a duplicate data and things.
Achha.
Okay, so that, see, like, again, if I try to give it on the name, every name is almost unique. See, there might be John repeated 2-3 times, I think, but most often it is unique. Okay, if I create based on the account name, so if I have 5,000 customer, out of that 5,000 might be 1,000 customers name might be duplicated, 4,000 will be unique. So index table also will have that 4,000 rows, and then what happens, it is creating on your memory RAM. So your RAM might run out of space. So that kind of issues can happen if you create it on this kind of columns. So that is where we should be very wisely in deciding, when to use that indexes. Sometimes, if you're not very sure about it, leave it. Not an issue. But if you're using it, you have to use it very wisely.
Okay.
I think that is the consideration, the following when non-clustered, and add an index only when it is extremely necessary. As you said, it is going to have a lot of performance glitches. Index creator requires additional maintenance overhead, that is the RAM and all this thing. Index columns that are accessed very frequent, that means give the index only on those columns that is used in search very frequently. If not specified, that is when you're creating an index. See, in the syntax we saw create type of index, unique or clustered or non-clustered. All three were optional. If I'm not defining anything, by default it is going to create a non-clustered index. If I say create index, name of index on table name and the bracket, if I say column name, if I'm not mentioning what type of index, by default it is going to be a non-clustered index. Yep.
Got it.
Use a non-cluster, that is when you're creating a new index, and if I'm not specifying the type of index, it is a non-clustered index. Okay, apart from that, I said when you define a primary key constraint or a unique constraint, that will also create a index automatically, and that is going to be a clustered index. Okay, I'll show you practically that also. Use a non-clustered index for the columns that contains a high number of distinct. Yeah, this was the important point. So, okay, clear?
Yeah.
A composite index consists of 2 or more columns which is indexed together. Okay, that was about your clustered and the non-clustered.
Non-clustered.
Yeah. Apart from that, so we do also have a discussion about composite and unique index. A composite, when I say we discussed about composite primary key,
Correct, correct.
during the constant time. That means two
Correct.
fields together we are making as one primary key. That was a composite primary key. So a composite index consists of two or more columns which is indexed together as a one single unit. So like just like your roll number
and class.
yeah,
Roll number
class
and
and
class.
section all three together. Maximum
Yeah.
16 columns can be combined together as one. This one.
Okay.
They give always the max. Don't try with the max. 2 or 3. Okay. Don't unnecessarily combine all the columns and make that. So you okay.
Right.
The objective will not be met. But so when these people are giving, they always give the maximum thing, the worst case scenarios kind of thing.
Right.
Composite index requires the fewer overheads than a single column index. So something like so roll number and semester number together as one index they are trying to create. Okay.
Okay.
Consider following guidelines when you're creating a composite index. Smaller index are more effective than the larger index. That means don't give the indexing on the descriptive subjective columns. Give it only in the objective columns. Create a composite index when you search two columns or more columns as a single unit. Okay? Create composite index for the columns which are accessed together very frequently. Okay? Do not index columns that are too large since it takes very long time to retrieve the data. Yep.
Do not index columns that are too large.
That means subjective columns.
Subjective bole to?
Subjective bole to like suggestions. You're storing a column called as suggestions. We are storing the suggestion address.
Achha.
Okay, is
Achha.
there? So don't try to give because the data itself is almost we rarely search based on that column, so it is not suggested to the index. Unique and unique index ensure that index column contains no duplicate values. Both clustered and non-clustered index can be unique. Okay, so this will ensure when you define a unique, the data should be maintained unique within that table. Okay, so that means when you create a primary key, this particular constraint will be created. A unique clustered index will be created. Specifying a unique index makes sense only when a uniqueness is the characteristics of the data, like say mobile number, email ID, and all those things. If uniqueness must be enforced to ensure the data integrity, create a unique or a primary key constraint on the column rather than the unique index. Okay, so instead of creating a unique index, so create a primary key constraint or a unique constraint that in turn will automatically create the indexes also.
Picture slide jaiye please. Previous slide. Okay, previous. Sorry, previous. Composite index consists of. This is just an example, right? Roll number and semester, because roll number and semester is may not be. No, if I'm giving a unique or a primary of roll number and semester, they become primary, which means it will only have unique values, no?
So together you're going to make a composite primary key there here also. Composite means together they should not be repeated.
Correct. So यहाँ पे composite index का बनाने का कुछ फायदा नहीं है ना?
Generally, when you define this particular constraint, the index will be created automatically. Right. Even the unique index will be created automatically. The primary key, if you define a primary key or a composite primary key or a unique constraint, the indexes will be created automatically.
Oh, acha. Okay. Okay, got it. Yeah.
Fine. So the difference between a clustered and non-clustered. So clustered index used for queries that return large result sets. Non-clustered used for the queries that do not return the larger result set. A clustered index can be created. Index can be created on a table. That is, we can have only one clustered index can be created on a table. Whereas in the case of a non-clustered, you can have multiple. It was 249 was the max thing, no? The data is stored in the sorted key. That means on whichever the column you have given a clustered index, the data will be sorted based on that column and will be stored. Whereas in the case of non, the data is not sorted in a sorted manner on the case of a non-clustered index.
Okay.
Now we need to get into a practical. So we have understood what is the purpose of the index. We have understood the different types of index. We have a clustered and the non-clustered. Apart from that, we have a unique and composite. That is the reason, like, they don't talk about unique and the composite. The composite is whenever you define a composite primary key, by default it has been created, and unique also is not recommended for you to create a unique. If I, on that particular column, if you define a unique constraint, the unique index also will be created. Okay, that is the reason most of the authors, they don't discuss about a unique and a composite. So, but major two types is your clustered and the non-clustered. Okay. This is how you write thing. Create clustered index. So that means I'm creating a new index called the name of the index. So here says we are telling, okay, this is a clustered index. So that means if I don't specify, this is optional. So that is going to be a non-clustered index according to the slides what we have seen. Okay. On table name and the column. This is the syntax. This is the actual cluster. Create cluster index IDX customer ID on customer details table. In the table customer ID. That means the customer ID column of this table will be having a clustered index. If I write the query, only this much. Very simple, very easy. Create. Okay. So this also is optional. So you want to create a clustered index. We say clustered index, name of the index on the respective table on which you want to give the index, and it will be given for the column of the table. So the table name and the column name, because the column names are not unique in the database. So it is unique within the table.
Correct.
Yes, Francis?
Yeah, Sadiq.
Yeah.
Tell me.
Yeah. Getting no?
Not really, because my net and your voice is breaking literally.
Yeah,
I'm just trying to see the notes.
Yeah, I know.
Because you're going too fast, I
thing
guess,
with
today.
notes. Don't worry, I'm just recording this. So
Okay,
at the
maybe.
end of the session, okay, I'll just try to forward this recording.
Maybe.
Okay, fine. We'll see practically how do we go about it. So I think. I think you can see my desktop and all the applications, no?
Yeah.
Let us do one thing. Let me create a table. Okay, I say create table. I say name of the table. I say test table, or maybe emp table or something, and then I'll just create emp id int. Let me define a primary key. I'll leave it. I say emp name. And say designation. Okay, sure. I'm just creating this, and let me run this. Table is created. So once I have created this table, I'll just say refresh. So you can see there is a table created called as emp table. Yeah.
Right.
Okay. And you can see in the indexes, there is no indexes there.
Right.
So that means I have created this emp table, and you can see the indexes are empty. That doesn't have any index. Now, if you want to manually create an index, how do we create? We say create in what is say cluster index. Name of the index, I just say idx or say on emp id or something, and on which table, the table name is emp table, and in the emp table, for which column you want to create this clustered index, so on which column it is going to be suitable according to the explanation. So this is a clustered index. So no, it's a clustered index. No, clustered index ensures the data is unique in that.
Achha.
Designations ke liye non-clustered will be more suitable.
Right.
Okay, it's like a dictionary and thing. The sorting happens and things. Command completed successfully. So now when I try to refresh this, yep. So you can see there is an index which is created as IDX EMP. So you can see I created the index IDX EMP ID. It is the index is created. Okay.
Right.
Okay. So here what happens, when you have a small data, even 100 rows or 500,000 rows, you'll not be able to find the difference. But when you have the lakhs of rows, when you write a query, you will be able to find a difference in fetching the data if you have implemented the indexes.
Right.
Okay. This is way how we create it. So now what I'll do is I can drop this index. How do you drop the index?
What happens once you create that index? I mean,
we are just telling the compiler you change the way this search has to happen. We are changing the searching technique. See, if I use the clustered index, I said it is like a dictionary. So since you have created on the emp ID, whenever you are searching, the data first will be sorted based on the emp ID, and then it will look for the actual employee number that you are looking for, and then it will locate it. It will fetch that complete row and it will show you. It's something like your dictionary.
Show me one.
I think you missed out the session in the starting. Okay.
That's why you.
Yeah.
Just
See,
show
actually,
me one. How do we?
the index bolne se kya hota hai is like, we are just telling the compiler, you change the way you are going to search for the data.
Okay.
Okay.
Yeah.
Fine. So what I'll do is, let me drop this. Delete the object. I'll just say okay. Okay, I have deleted. Now what I will do is, see, there is no index now. There is no index. Now I'll just define a primary key. I'm not defining any index. I'm just creating the same table where I'm making employee ID as a primary key. I'll drop this first. Drop table. Table को भी मैंने drop कर रहा हूँ. Okay. Right. I'm just recreating. Now the table also does not exist. Okay. There is no table, emp table. So let me recreate this. I'm just recreating it. So now when you see these tables, refresh, there is an emp table. When you expand this and you go to the indexes, there you can see that index is created.
Wow.
Got it. So that means no need of writing this particular query also. By default, it gets created when you define a primary key. Now you want to see what type of index it is. You can just right click on that and properties. And there you can see this particular options telling like what type of index and a thing. Yeah. So now let us try see, like even you can create the index later stage also. So one way to create an index is through the code. Now you want to do it in the enterprise way, yeah, you can still do it. Now imagine I want to create an index on the designation. I want to create a non-clustered index. Like I wanted to have a search because we have many employees will be working for the HR department. I want to see all the employees working for the HR department. I want to see all the employees working for the IT departments or finance department or something. So in that case, what I will do is I want to define a non-clustered index on the designation. So I'll just right click on this particular index. I want to create a new index. Okay. And when I see here, right click, new index, and I'm trying to create. By default, we can see clustered is disabled. You know why?
Because only once you can use it.
Yeah, only once you can have. So if I was not having a clustered index, would have given an option of doing this also. Now it says this is ruled out. You don't have an option. So only thing that you can do is only this one. Okay. So what we do, right click on this new index. We say non-clustered index. I just hit on that. Okay. And then here it says on which table, emp table. So index name, it says it's a non-clustered index and the name is given automatically by the machine. So it says 2020-03-29. That is the current date. with hours, 16 hours, 11 minutes, 46 seconds, and so on. Okay. You want to give a different name, you can just say, I say non-clustered IDX, non-clustered index on the designation column. Okay. You can go with the default name or whatever the name you want, you can give it. And you can see index type by default says non-clustered index. Okay. Now your clustered index or non-clustered index can also be unique. If I say unique, it'll ensure the data is unique. If I say no, okay, no problem. Okay. So, and I just say add on which column. So now, okay, as soon as I click on this add button, so you can see when I click on this particular add button, it is invoking this. So here it says in which column you want to apply. I want to apply on the designation. So I just need to check this. So what I will do, I'll just tick this and I say okay, fine. And I okay, so now you're trying to create on the designation column, you're trying to create a non-clustered index. This is the name of the index, this is the name of the table. Fine. You want to see the script, how it has been generated. So you can generate a query script also, and you can see how the script has been written. So let me say okay, now the index will be created. Okay. So if I'm manually writing, we say create non-clustered index, name of the index on the table name and this column. Optionally, it is giving the pad index is off and all these things.
Right.
It's easy, no?
Yep.
So again, this what happens, you know, when there is some kind of a performance factors and all those things. That time, you know, the administrators they look into this particular thing. So whether to improve the performance, whether the indexes has to be used, or sometimes, you know, the administrators they give the suggestion for the database developers, telling that, you know, there is a performance this one. So if you add an index, you might get a better performance. So okay. So anything related to performance and all these things, you know, the question will be asked for the DBA guys, database administrators guys. And those people will work on that, or they'll pass on the information to the developers telling that, okay, on this you need to create so and so indexes. Okay.
Got it. Now, unique is a constraint or a key?
Unique is a constraint.
If you create a unique, for some reason in mine, it is coming under keys. It's not coming under constraints.
For a column, is it?
Yeah.
The example. Yeah, okay, something like this. I'm dropping everything. When I drop the whole constraints, everything goes. Right. If I try to recreate this, refresh. Primary key also will, primary key also, both are coming on the keys itself.
I was wondering because unique is supposed to be a constraint, so I was searching in constraints, but it was there in keys.
Okay.
Weird, no?
Okay, it's a key field, no? Like, you know, it's used for identification purpose.
So correct, but you will type as constraint only, no? If you have to do it outside the table,
yeah,
you will do a constraint only. You will not put.
Yeah, this name will say pk_m table of UK. It is creating based on the key itself. It is not coming on the constraint. But if you give a check constraint, it's coming under constraint, no?
Check.
Check default, not null and things. Check karo.
Check मैंने observe नहीं किया.
No, it is like telling like it's a unique identification column something.
Correct. But when we write a unique, it is we write constraint.
Yeah, we say constraint. Even primary key is a constraint, but it is coming on the key itself.
Right. ठीक है.
Okay. Thanks.
Yeah.
Okay.
Merge was very, though it is very simple to understand, to execute it was very, confusing actually.
Okay.
I understood the concept, but you know, if you see my WhatsApp, that was a pretty big code.
Okay. See, like, you can do it in the enterprise way like this. Go for the index. So you want to create any index, no, on the respective table.
Okay.
We just go to the index, right click, new index. So then we select whether you want a unique, non-clustered, or clustered. Since you already have one clustered index, otherwise you'll get a drop down here. You can select those, and then you can include the columns that you want to apply, on which all the columns you want to apply. Okay, and then the name, and then say okay. That will get created.
Okay.
Okay, so all those options are there. The same thing they are trying to show with this one. Fine.
Right.
Okay. Fill factor says option to reserve space on the leaf page of an index for adding additional data at a later stage. When an index is created or rebuilt, fill factor specifies the percentage of space on a page to be filled with the data. So something like, when you look into this, I said behind, like when you saw the architecture, we have a physical storage and the what is a logical display for us. Physically, it stores in the form of files. Each file will have a information which is stored in the form of a pages, like a book. Okay, we'll have a pages. One page is filled, second page and thing. So in the book, we have a header and the footer section, so that your notes can be more easily. It will be good looking. One thing. The second thing is some kind of additional remarks you want to pass it. You can take that space, no, the header or the footer space. I can utilize for that purpose. Yeah.
Correct.
Okay.
Correct.
The similar kind of thing here. What happens in the page? So we can specify. If I say fill factor as 20. So it says like 80% will be filled with the data, 20% will be left over. Fill factor can be set to our percentage from 1 to 100. The default factor value is 0. The fill factor of 100 is used only in read only. If I say fill factor 100%, so that means here you are not doing any kind of updates. So mainly we use this when you're doing some kind of updates and all these things. So if I have some additional space, so it page level wise, it can do an updates. Yeah. Okay, so they use this particular fill factor. With fill factor is equal to percentage of fill factor, we can specify. I think pad index is like, how many empty rows has to be left at the end of the page. Okay, so ये भी जो है ना आपका वो जो index जब बनाते हैं उसी टाइम पे we can specify that. Let's say new non-clustered index. So if I'm creating on the column, say designation, say okay, and when you go to this particular option, so here we have the fill factor and thing, so we should be able to specify. If I say 80% is going to be filled, 2% will be left off. So whether you want to have a pad index, true or false, so you want to give that space. Okay, I think on each row wise. So fill factor is mainly used for the updates. Okay, DML operations. Pad index is like, sorting the data. So if there is empty rows, the page level wise sorting can be done.
Okay.
Okay, so उधर ही करेंगे तो automatically वो query भी ऐसे ही generate हो जाएगा. Okay, so this is something to do with the indexing. To view the indexes, we have the SP help index, name of the table. Yeah, this showing with the management studio, what I showed just now. You can temporarily disable the indexes. Okay, so in that case, we say alter name of the index, okay, on the respective table and say disable. So this is like, you want to disable the index for a temporary period of time. The indexes will be there, and later you can use the same alter command with enable to enable back that index.
Okay.
Right? And things. Dropping is, so we use a drop index, name of the index on table name. You're not using the alter table, but here you're telling drop index, name of the index, drop index on this table. Drop the name of the index on the respective table. So in this table, this index will be removed.
Right.
Okay. Fine. Yeah. So समझ में आ गया?
Yep.
Okay. Fine. that was something to do with indexes. So now you had a question on merge. Francis, hello.
Yeah.
You got some idea of what is index?
Yeah.
Yep.
See, I maybe yes, a little bit, yeah, not
Okay.
completely,
Okay.
because I just want to know you. I've seen you updating and all, but what is the benefit? How do we take the data and see? That is what I want to see.
Okay. See,
I
there is some
understand,
kind
but
of there is a compilation window. They look into the speed. They look into, like, when you write a query, they try to find out how much time. There is something called as the execution plan. So then you use by the DBA guys. So there is something called as a execution plan. So when you write any query, I think display estimated execution plan. So
no,
here
with
when you
the
run
index,
any
what you
query,
have created.
this will give you a kind of a plan, how much time it has taken. So now they try to put an index, and then try to find out, like, how much time they have taken. Without index, how much time it is taking to execute the query. Generally they say, like, if you are using the indexes, it might save even 80% of your time. That means if it is taking say 1 second to execute, or say 10 seconds to execute, with the index it might take 2 seconds to execute. So it doesn't go in seconds, it goes in the milliseconds or a fractional of seconds and thing. So they look into those particular things. So that is what.
Francis, if your question is about how to execute the index or how to call the
No.
index,
See,
we are not calling it.
yeah, he's done
Yeah.
it 3, right? So what am I supposed to do with this 3? He has written it, use index, whatever, create
Correct.
cluster. So what is that? No, what am I supposed to do with that?
See, what happens is, as Sadiq sir was telling, it is only at the back end, that's all. In fact, we have got nothing to do with it. So when you do an index, the speed of the execution will become faster.
Okay.
That's it. You're not calling the index anywhere, or you're not doing anything else. When you say index, the speed becomes faster.
Just like how you read the books. So we have one way to read is like first page, second page, third page. The other way to read is like, okay, look for what exactly you are looking in that particular book, and jump to that location and read only that particular content instead of reading the complete story.
Okay.
Yeah, Francis.
Yeah, but
Yeah.
now since you created,
Yeah.
now it will take me and show me directly what data I'm.
See, like, there is a compiler. No, when you write a select statement, there is a compiler which compiles that query, and it takes the responsibility of executing that. So during the execution time, okay, we are telling the compiler, okay, since you've given an index, you retrieve the data in this particular style, in this particular way.
Okay.
So one thing is, when I use a clustered, so the data will be sorted and then the fetching will happen. And if you have used a non-clustered, so it gathers all the distinct values, creates a separate table, a link will be created for every row. It goes directly to that particular rows and it fetches. See, something like, if a table has 1 lakh rows, and out of that particular 1 lakh rows, I want to look for Francis. Okay, so now what I will do is, the Francis is the name. Okay, so imagine it's the first name. On the first name, I'll try to create a clustered index. When I go with a clustered index, so the data will be sorted. Okay, when it is sorted, then it goes A, B, C, D, F, Francis. If it finds a Francis, it will fetch the Francis. There is a possibility where there might be a second Francis also. So if there is a second Francis, that Francis will be immediately next below that. It will fetch that. After that, if it is FG, something like, Girish or somebody is there. So that means after this, it is very clear that we'll not be able to find further Francis. Okay, just imagine if you have not given an index. So if you have 10 lakhs rows, the Francis was being found somewhere in the 500th row. So fetch was happening only 500 record it was fetched, and then it confirmed that, okay, in further it is not going to be there. But if you have not applied this particular kind of sorting or a class indexes, so then it has to go from the first till the last. So even though your name was being found in the first 100 places or something, but still it has to go till last, because it might be another Francis might be present somewhere even in the last also. Got it?
Okay. Okay. Okay.
Yeah, no, you go anywhere and you're searching. Even when you go to the election, this one, no, when you're searching for your name or thing, so we just look into your house number or something. So yeah, if it is there in that list, it is fine. If it is not there, okay, there is no point in going there further and fetching. Yeah, got it.
Yeah, yeah.
Okay, so yeah, that is like, and there are two techniques. One is the sorting, another one is your gathering your distinct values and then creating a link to the columns and then fetching. Okay, I think. Another one we thought of we'll discuss is merge. Hanji, quotes.
I'm here.
Yeah. So we'll talk about merge query. That was about your index. So now we'll go with merge. Okay. So merge के बारे में मैंने I think I discussed when we were talking about a DML operation, insert, update, delete, and but I did not go practically into that. So I said there is also a merge command. So where the data can be transferred from one table to the another table. Okay,
Right.
but when you're transferring, it is we have something called a append query and all this thing. So this is doing a job of both append as well as the insert, both append and insert. Okay.
Okay.
So append query करके SQL में नहीं है, access में and all we have something called append. Append is like you're transferring the data from one table to another table. If the data already exists, it just overwrites it. Okay. Insert is
Okay.
like what happens, data is transferred from a source table to the destination table. Okay.
Okay.
Yeah. So again, it's a DML commands itself, insert, update, delete, but conditional updates we can call it as. Okay. So based on the condition, either you want to do an insert or update or a delete. So we use a merge. Now, to understand this merge, I have created this table here called as the actual emp table, EMP table.
Okay.
I've created emp table with this columns here. Employee ID, okay, employee name, designation, and salary. I've created 4 fields and have inserted some data into this particular table. So let me.
Can you drop 2 tables at one go? Like drop table EMP, comma, EMP underscore backup.
ज़्यादा से ज़्यादा एक error आएगा ना?
उतना ही ना.
Okay, cannot drop table M because it does not exist. Abhi to right now they don't exist. Let me. Okay. Command completed successfully. Yeah, that's it.
Nice.
Sometimes we learn based on the questions. No, we need to accept.
Correct.
Either. Okay, fine. Chalo. Now, I have created these tables here. One is the M table. So I have, this is my actual employees, I can say, with the some fields and just inserting some data here, Sadiq, Sam, and Ben. So with the employee number 1, 2, 3, fine. And also have an employee backup. So employee backup is what? So, okay, I want to make a backup of this particular data. So backup is maintained, okay, where the you see what happens, the updates will not happen in the backup. So it is only for the safety purpose. So might be at the end of the day, whatever the data is here, I just try to push it in the backup. Okay. So I want at the end of the day, whatever the data is here, and this should be the same, but active data will be working on this. See, tomorrow, if my database gets crashed or anything, still I can get the data from the last backup, something like that. Okay. So now, based on that, I have created, and you can see one record, one Sadiq trainer. Okay, no records are matching. No, let us have one common record. 2 Sam trainer 3500. This record is same in both.
Right.
Okay. This record purposely I've made it as same in both. So they are same exactly even in the backup as well as in this. Whereas in the case of one Sadiq, here I've given trainer, here I've given faculty. So here it is 3, here it is 13. Okay. And I do also have an additional record in the backup. Fine. So I have 3 records here. I have 4 records. So let us add one more record here. Say employee 4, say Francis, CIS. Okay. Say what is the manager? Okay. Enough, no? Say 55,000. I think I have data also in both. So what I have done here is I have 2 tables here. This is my M table, the active employees table, and this is my retired M table. Fine. Okay. So now in my sorry, not retired. It is a backup table, no?
Yeah, backup.
M backup or whatever it is. Fine. So this is my backup table. Now what I want is at the end of the day, so when I run this particular merge, the data from this table has to be transferred to this. So there is something called as a source table and there is something called as a target table.
Okay.
Okay. Source to a destination, nothing. So now I want to transfer the data from the actual employee to the backup. Backup is my target. So where I want to push my all my data, what are the new updates I have done. Okay. That is from the source to the target I want to transfer. So when I'm transferring, there might be some records which is same. Now, if it is same, I don't want to do anything. Now, there is some records which is mapped based on the key field. That means all the records will be mapped based on the key field. If the same key is there, I just want an update. So that is the name to name. Okay, designation. This designation has to be shifted to this. Okay, this salary has to be shifted to this. Okay, this will go to this.
Right.
Okay, and there is the key field over here 4, which does not exist here. Okay, which does not exist. If it is not existing, what I need to do? I need to write an insert command to insert that row. So that means the 4 has to come here, the Francis has to come here, manager 55,000. Okay, 5,500. Cool, that has to happen. And when it comes to 3, okay, the key field does not match.
Right.
Yeah. So what happens? Now, how do we write?
Row will be added.
Yeah. Now, if there is a key field, same key field, it will do an update based on the match key field. And if the complete row is there, it will just try to write a. If it is not there, like say 4, it is going to be deleted. And other thing is, okay, fine. 3 is here, but it is not here. 3 is there in the source. That means the EMP table, but is not there in the backup table. So what happens? This record will be added as a new record. But when it comes to 2, the same record is there. Okay, it is not going to do anything. Okay, and when it comes to this particular, what you say, 55, it is there in the backup. It is not there in the this one. It is not there in the other one. So in that case, what happens? What I mean? In that case, I want to remove the data from the backup. There is an additional row in my backup table which is not needed for me, which has to be removed. Okay. Okay. Okay.
40 minutes up, is it?
40 minutes. This is actually I have taken the license.
Oh, you have taken the license. Okay.
Yeah, it ran more than 40 minutes. No? No, call आ गया disconnect हो गया.
Oh, okay.
Okay, sorry. Yesterday morning we purchased. Yesterday also it was running. No? Okay.
Oh, is it okay?
Okay. Fine. Well, let us see like how do we use this particular merge. Amina is disturbing a lot. Okay, I know. She's coming for lunch. I'll take a break after 10 minutes. Okay.
Not for lunch.
10-15 minutes. Okay. 45. Okay, sorry.
No problem.
Okay. So I've just written this particular merge. So the merge command is something like this. Merge itself is a query. So now we say target table using the source table. I can create an alias name is optional. So I have created an alias name target as TSS source. Means target is to where, which table you want to dump the data. Source is from where you want to dump the data. Okay,
Right.
that is something like, you know, you're transferring the data from one table to the another table. So I say I want to transfer the data from the EMP table to the EMP backup. Okay, see, it's something like, you know, when I say declare a variable, if I say variable is equal to 10, a is equal to 10, 10 will be assigned to a. That means always it is from right hand side to the left hand side. The same way your right hand side table's data will be assigned to the left hand table. Okay, merge this one. On how you are going to merge, there should be a common field based on which you are trying to say whether this particular record is there. If the matching record is there, it has to just do an updates. If the matching record is not there, something like you see 1 2, there is a matching record is there, so in that case it just has to update. Sadiq is there, fine, but here designation is trainer, here it is faculty, so that means the backup should get a new designation as a trainer. Okay, so from 35 to 100 it has to become to 400. For 2 again, okay, it has to do an what is it, just a updates. But when it comes to 3, it does not exist here, it has to insert. 4, it does not here exist, it has to insert. Whereas 13 and 56, it is here but it is not here. So in that case, okay, from the destination table, that is an excess data that I want it to be removed. Delete. If you want, you can go for it. If not, that also you can leave it. I can even have a retain the old data also.
Okay, because backup everything should be there, no?
Yeah, if you want, you can retain that. If, or sometimes, you know, you don't want that, you can also remove. Okay, so that means merge does all the 3 operations. So we say merge. Okay, so from which table to which table? So that is first we specify the target using the source table. So on what is the common column in both? So when you look into this, both the tables have created a similar kind of column names and things, emp id. So I say both are being matched. The key field is the emp id. So since I have given the alias name, so I am referring with the alias name, that is backup table ka emp id matching to the source table ka emp id. Fine. Now based on the emp id matching, if match is found, match is found is like say 1 and 2 is been matching. When match is found, in that case I just say update. Now what update has to happen? From the source table, take the name, push to the name column of the destination table. Designation, push to the designation. Salary, push to the this one. So what happens? Something like name Sadiq will be pushed here. Trainer, so trainer will go. So that means this designation over here has to change to trainer. So this value has to be changed. So even in the case of 2, okay, it'll overwrite again. So it is the same values here, Sam, trainer, this one, but again it is going to use the update because it is a common columns is matching. Now if there is no match, like 3 4 is here and 13 this, if there is no match over here, so in that case what we are trying to do is we are trying to write a insert command. That means here 3 and 4 is no matching in there, so I say insert. When I use the insert command, I just say insert. So I need to take the emp id, employee name, designation, that is, so we'll be inserting the data into the backup table. That is my target. So we are matching to the target table. So I've just called that particular column values from where you are fetching. So we are fetching from the source table. Get the emp id from the source table, name, designation, and salary from the source table will be added. Fine. Yeah. So that means 3 and 4 it is going to be updated. Apart from that, we do also have when not matched. Okay, by source. That means it is if some records is not matching with the source, like say 13 and 55, it is not matching with this. So then I say delete. Now this is optional. Okay, if this is optional. Okay, so now let us do one thing is, let me run this merge. I've removed the delete wala. If I run this, terminate with the semicolon. Yep. 4 rows affected. So now when you look into this particular query, whatever the data was here, so 1 2, So 1 and 2, you can see Sadiq trainer. So you can see they got this particular value, what was there.
Correct.
Okay. And 3 and 4, which was not here. It was not there
Was
in the
added.
backup. It was there in the employee. It got added as an additional record. But 13 and 55, it has retained as it is.
Right.
Okay. If you don't want to retain that, so in that case, so you can also say when not matched by source. That means there is no matching data in the source, you would delete that. So if I try to run with this, you can see that 13 and 55 will be removed.
Removed.
So 6 rows affected.
Yes, select B, select start from employee, comma, employee underscore backup.
No. Then it is going to be a join. It will work. It will not throw you an error, but it will create a join with both the table, and you have not defined a joining condition. So it will try to create a permutation and combination of rows. ये joins में हमने किया था इसको. फिर उसके बाद हमने बोला ना, where if you don't give a where clause, it happens like this.
Right.
So yeah, merge is like a conditional update. Okay, you want to transfer the data from one existing table to another existing table. Mainly like, you want to take up backups and all these things. We use this. So here we have 3 criteria. Okay, if the key, that is, we merge the data based on the key field. If the matching key fields are there, I just want to do the updates. If the matching key fields are not there, then I want to transfer that records to the destination table, the target tables. Yeah, if there is no matching data from the source in that, but it is there in the target. So that records, if you want to delete, we can use this. Okay. So 3 things can be given, optional. Yes, Francis.
Francis, unmute, yeah.
Yeah. A kid is playing. That's why I put it on mute.
No problem. Sadiq sir was asking, did you get it?
Yeah. Kind of. Just make a note of it.
This is not sounding positive. Sound is very low. Francis. You got a headphones? Francis? Yeah.
Yes, I got.
You got it from your friend. Okay, fine.
Yeah.
Okay, the voice is audible, clear?
Yeah, no, it's fine, clear.
It's fine in things. So the net connection is also fine in your end.
Yes.
Okay.
Why is sounding so low, yeah, Francis?
Just trying to understand these things. Timing getting almost, we're finishing now. That's why.
So you're feeling bad, is it? No, we'll still see.
No. You have to practice.
There is a
You
song,
have to practice. No,
college bandh ho jayegi.
Now, main concern is now I have to see how we will use this. All this while we are only learning. Whatever we are learning, it's only like, how to fetch, how to take, but we are not doing it in a real time. Corporate, how they work.
Yeah. See,
So
like,
the
quotes, what he has sent the WhatsApp, no, I was just looking into that particular link. That is really a good one. That you have looked into that WhatsApp in this one?
No, not yet. I thought
that
we
link,
do
the
it
queries
today.
are there, and you have to use that editor because the data, everything they are providing. Yeah.
Yeah.
Where is that?
Yeah, that is why I'm worried from yesterday. How are we going to use it in real time? Because the concepts we know, how is that we're going to use it in corporate world? Some examples.
See, this particular example is really like, the real time kind of thing. S quotes.
Yeah.
W3 resources, what you have shared. Okay, so it is shared in the WhatsApp group. So you have an exercise with the solution is there, but don't go to the solution. You try to handle it. So here it says write a SQL query to display all the information of all the salesmen. So you want to write the query. Just get into this particular code editor and then try to write the query over here. So it is actual table name is what? Salesman, no?
Select star from
Select
sales.
star from the salesman and try to click on submit. Okay, if it is fine, you'll get an output. So if not, it will throw you an error. Try to identify the error and rectify. So they're giving even the solution also. Okay, solution you can try it in the later, in the worst case, like if you're not able to answer that. So in that case, they explain you, okay, select star from the table name and all these things.
No,
And I
this
think
is
they
exercise
have
33.
this particular exercise for each and every module, no? So when you
Correct.
see in the left hand side, they have almost a lot of good examples are there. Boolean, relational operator, how to use a wildcard operator, aggregates. So yeah, union, views, almost joins, and thing. This is mainly we'll be using, not like uh, stored procedures is one time you'll be using. So again, they'll be used by the top level people. So because things, and it has been created once, it will be called again and again. But this particular queries are something like which has to be more creative. Again, when it comes to views or stored procedure or something, so you'll be using this inside that.
I'm happy at least you saw it. Nobody else has seen it. Hello?
Francis.
Yeah. No, I'll see, man. I'll see today.
Okay.
Cool.
We thought we are doing that today. That's why.
Oh.
इसको आपको करना है and you have to forward the solutions for me.
हाँ पक्का.
Okay. Nee, this
तो
is
आप भी
good.
online पे आ
Or you can
जाइए.
go even for hacker rank.
Hacker rank, is it?
Hacker rank. Usme bhi they have similar kind of thing. But that examples, most of the answers, it was very difficult. But usme ek hai chat form hai. So where everybody, like you can ask a question in the general, this one. So there are people who explain about that and things. And
You
usme
need
bhi
to
you
log
get
in and
even
all.
coins like GUI and all this thing, but it is free.
अच्छा.
Okay, but it is interesting, like you have it's like a form has tech forms here, so you can put a questions there, they'll give an explanation why, how, and that queries and all this thing, but that queries are little higher end mein, but it is really interesting.
Super.
And there wahan pe hai na ek particular question deta hai, and you can answer either using a MySQL or Oracle or MS SQL. So you just need to say, drop down a box, and then you can say whichever the language you are comfortable, you can write it. So because there is almost slight difference in MySQL, SQL, and Oracle, so you can try. And even the questionnaires will be shared, and discussion forums and all are there in that. Hacker rank, maybe. Yeah. So they have it for many, this one. So for database also they have, and that is really good. The questions and all these things, what is there?
अच्छा. ठीक है, तो आप खाना खा लीजिए, उसके बाद शायद हम पिवट देखें.
हाँ, पिवट उसके बाद देखेंगे. So now it is 5. What time we'll meet up?
It's 4:50. Shall we come back at? How long would you take to finish off lunch, sir?
Lunch so 15-20 minutes. Then I'll just perform my prayer salah time. 5 o'clock prayers are there. I'll just finish that. Might be 5:30 or 5:40. We can meet us. So you have something for practice now. Huh?
हाँ, 40 minutes. ठीक है. 5:30 will catch up.
Yeah. So you have a lot of things to practice now. Okay. You also need a break first thing. Okay. Then थोड़ा practice कर लो. We'll get back. Okay.
काय का break? इधर बाहर भी नहीं जा सकते.
बाहर
Complex
नहीं
के अंदर
जा
तो मैं
सकते. छुट्टा नहीं मार सकते.
मंदिर तो नहीं मारता हूँ मैं.
अच्छा. टेरेस नहीं है क्या?
नहीं, फिर भी ऊपर जाके नहीं मारता हूँ.
अच्छा.
Sadiq. ठीक है. We'll meet up at 5:30.
Okay.
Francis, I'll get on a call with you here.
You're getting cigarettes, sir? You get a cigarettes, huh?
No, I already bought a pack, but I don't do it inside. I think his kid is over there. I don't want to speak. I'll connect with you, Francis.
Yeah.